So hi techies, welcome back to the channel. And starting today, we will be making another playlist on machine learning algorithms. We have made a complete playlist on the Python libraries which we use in machine learning, and we are now making a playlist on machine learning algorithm. Next, I would be making a playlist on Python, and after all this, we will start making some advanced project on machine learning, deep learning, generative AI, and RAG. So these are all the basics. Algorithms are the basics, Python libraries are the basics, and all these are the basics. So without all this, you can't be able to do advanced math machine learning project. And so let's start with the very basic and first algorithm. As you can see on your screen is linear regression. So basically it is a regression algorithm. Let me explain you first. We have machine learning. Inside machine learning, we have basically two uh, um, um, uh, divisions: supervised machine learning and unsupervised machine learning. We have reinforcement learning also, the third one, reinforcement machine learning. But basically, we are be learning about most of the algorithms are of supervised and unsupervised learning. In supervised learning is also been bifurcated into two parts: regression and classification. And it is basically been divided into reinforcement learning. So what is regression, classification, reinforcement learning? So basically, whenever your output is coming in yes or no, yes, no, and like there is a choice, yes or no, it is a classification. Regression is whenever your output is coming in numerical value or a continuous value, like 1, 2, 3, and all that. It is a regression algorithm. We will be using regression algorithm. And whenever you are identifying the patterns and all that, it will come into reinforcement learning, and a specific algorithm will be used there. Why in every machine learning you should know regression, classification, or reinforcement? Why? Because you should know which algorithm which you will be, it will help you identify which algorithm which will you be using. It is not like you can use classification algorithm in regression or regression algorithm in classification. Your project will go wrong in that. So that's why basically first we have to know how to identify the things, right? Then only you can do. Some of the projects of regression I made is car price prediction. You can find it in my channel. House price prediction. And classification, I made employee attrition. Iris flower classification. And like two, three more projects of classification I made, but right now I'm remembering these only. So basically, iris flower was, there were three categories. It is not that there would be only yes or no. It is binary. It is of binary classification. There can be three or four, then it will all be coming into classification, right? Understood till here? So some of the algorithm, like in regression we use linear regression algorithm, and in classification the basic fundamental is logistic regression. Don't get confused that here regression is coming so it would be of regression. No, it is a classification. We have random forest and many other algorithm are there. We have becoming whole decision tree, random forest, support vector machine, SVM, linear regression, logistic regression, naive Bayes, k-means, all the algorithm will be covering in this playlist. This is the first video of linear regression. And one thing more, linear regression, personally, I also feel a bit difficult to understand because there is a lot of maths included inside it. When I will be like, after the theory part, I will be coming maths. It is very obvious you will be getting confused in the things. But what you have to do, you have to again and again rewatch. Okay, if anything you are not understanding, use chat gpt, use copilot. These are all the things which we AI people use. Okay, so it's not a shame in using it. But if you will just watch my video, I will guarantee that you can understand it very easily. Okay, so suppose I take an example. We have a data set of a number of hours of study and pass. So if a person is studying for 1 hour, he will fail. 2 hour, he will fail. 3 hour, he will pass. 4 hour, it will pass, and 5 hour, it will pass. So this is the example I am taking for linear regression. Pass and fail. Okay, think for a second. Actually, I am taking the wrong example over here. Why? Because the output is coming over here is yes or no or pass or fail, which is a classification, and linear regression, as I told you, is of regression. So I can't use this example over here. Why I wrote, I want to see your presence of mind, that are you listening or not what I'm telling you. Okay, so this example I can't use. In logistic regression I will use it. It is algorithm of classification. Then I will, same example I will use, don't worry. But here I can't use this example. Okay, so let's start with some real example now. Suppose we have weight, which is in kgs. Another we have height, which we have in centimeter. Suppose the weight is 74 and the height is 150. Next we have 64 and the height is 156. Next we have 78 and the height is 171. Next we have 83 and the height we have is 166. So on the basis of weight, I want my algorithm to predict the height. Okay, like suppose I write over here 91, so it should predict that the height is suppose 175. Okay, so this is what I want. This is the independent variable and this is the dependent variable over here. Okay, got it. Now how it will work, I will tell you. First we have a trained data set. From that we have our implement our model, and then we have hypothesis. In our hypothesis, our input will be this is a short form of input, will be weight. As I told you, I will give input weight as input and it should predict, output should be coming as height. Okay, this is basically the objective of our algorithm over here. Okay, now I will make a graph over here. Let me take some more space, and yeah. Now coming to the algorithm, how this algorithm works. Suppose these are the points, these are the values. So what this algorithm do is make a best fit line. Okay, this is the core. This line which I am saying is the core, best fit line. Okay, these are your points. All the points are over here, and this is the best fit line. Okay, and these are the actual points which our dataset have, but these are the predicted points which our line is making. Okay, it is on this. So basically this. What is it? This distance is called? It is called the residual error. Okay, these are the actual points. And these are the predicted points predicted by the model. What I want is reduce the distance between the actual point and the predicted point, that is the residual error should be minimum. It cannot be zero. It cannot be zero. If it is zero, assume that your data is overfitting. But what should be our aim? To find best fit line with minimal error. Okay, suppose I give you new data, something like this. So what should it do? It should this, it will be predicting this. So this line is predicting this. Okay, our x-axis I forgot to write is our weight, and y-axis suppose is height, and this is a graph. So this graph basically represents the linear regression. Okay, I hope you got till now, and let's move forward to maths. The maths can be a bit tricky for you, but I would be explained in such a way that you will be understanding. Now coming to the maths. Okay. These are your points. Now, the equation of this line is given by y is equal to mx plus c, class 10th maths. But I would elaborate where y dash is the predicted points. Predicted points. What are the predicting points? I would tell you again. This is for this value. This is for this value. So basically the predicted points will always be on this best fit line. Okay, the line where it is predicting that our common line is going. Okay, m over here is slope or coefficient. Basically 1 unit increase in x, how much increase in y? Suppose 1 unit increase in x is how much increase in y. This is represented by x. I would write it here. 1 unit increase in x, how much increase in y. Next, C. Yeah, I think you must have got it. Intercept. So when x is 0, at what point it is meeting y? Yes, this point. This is basically your y. Okay. Now coming to the hypothesis of it, and the formula also I will be telling you. The formula is h theta of x of I is equal to theta naught plus theta 1 x of I. This is our hypothesis. Okay, what is x? X is the data points. This is x0 and this is theta 0 and this is theta 1. Okay, now here we are having just two data points, but if I say that we have many data, multiple input features, then what formula we will apply? The formula which we'll be using is h theta of x is equal to theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3 and so on how many data points we have, and plus theta n xn. So this formula you will be using for multiple points. For multiple input features. Now I will be explaining you with some of the help of example to make the things more clear to you. Okay, so our hypothesis, so basically you can say that y is a linear function of x. Okay, example if we take h theta of x is equal to theta plus theta 1 x1. Suppose I take theta 0 is equal to 1.5 and theta 1 is equal to 0. Put this value over here, simple maths, you will get 1.5. Now let's plot it. Here you are having 1, 2, 3 and it is increasing 1, 2, 3. Just guess it. Yeah, this is for 1.5. Okay, I've done nothing. I've kept 1.5 over here, plus I've kept theta 1 as 0, so it is becoming, whole is becoming 0 and only 1.5 is left. So at y axis I'm taking at is 1.5. Okay, next example if I take h naught x is equal to theta 0 theta 1 x1. Basically you know na, this is your intercept. Okay, and I give you theta naught is equal to 0 and theta 1 is equal to 0.5. So now this time 0 and here it will be 0.5 and we have 1 and 2. Our point is 2. So into 1 is equal to 0.5 and for 2 I will also do into 2 is 1. So and for 3 I can also do because there will be 3 points, into 3 is equal to 2. So 1, 2, 3 and 1, 2, 3. These are not 1, 2, 3 is this only. Okay, these are the points. So for 1 we are getting 0.5. It would be here something. For 2 we are getting 1. It would be here, and for here we are getting 2. Okay. So from the 0th axis it is going something straight line this like this. Okay. Simple. Now a very important terminology which is cost function. Now I will tell you the formula of cost function. it is 1 by summation of 1 by 2m h naught of theta xi minus yi by whole square. I will tell you why we are doing the square and all that, and we have just to minimize theta naught theta 1. Okay, now what we are doing, basically we are doing this is the formula first, and what we are doing first, square is done to make negative values positive. What is m over here? M is basically number of data points. You know that there is a derivative formula by x square by big theta of x, which is 2x2 minus 1, which is 2x or 2m. So that's why 2m is coming over here. What is 1 by m we are doing? To find the average of the difference in values. Okay. And 1 by 2 why we have used over here? To find slope when the value of theta is changed at last. Okay. So this is your derivative. And this is the formula of cost function. Right. Now, we have in terms of j also, j of theta naught comma theta 1 is equal to 1 by 2m summation of m I is equal to 1 h of theta xi minus yi and square. This is the formula. Our aim to minimize the cost function. We have to minimize the cost function, and the thing it is squared error function. Squared error function. And our aim is to minimize the cost function. Okay. Now I will tell you the difference between the hypothesis and the cost function, so it would be easier for you to understand. For hypothesis, and we have cost function. Okay, hypothesis is h theta of x, as I've written the formula previously also. I know that there is lot of maths, but you have to bear with me for some time, because you know maths is basically the main thing in this algorithm. Interviewer will also ask mainly the maths behind it. So just you have to listen carefully that what step and what approach I am using. Theta 1 by 2m, and here we have summation of m I is equal to 1 and h theta x of I minus y of I whole square, right? Let us assume that our theta naught is equal to 0. So first we will come for h theta of x, which is theta 1 x1. Okay, now we will be making 3 assumptions over here. First, this is our x-axis and this is our y-axis. 1, 2, 3. 1, 2 and 3. Okay, first we have for theta is equal to 1. For theta is equal to 1, I will write it over here. When theta 1 is equal to 1, So h of theta of x will become 1 into 1, h of theta of x will become 1 into 2, and h of theta of x will be becoming 1 into 3. Okay, the points we will be getting is 1 comma 1, 2 comma 2, and 3 comma 3. Now I will be using the cost function over here. The cost function you will be getting j of theta 1 is equal to 1 by 2m, and it is m over here, it is I is equal to 1 h theta of xi minus yi, and this is whole square. And as we know that our theta is the value 0 right now, so we will be getting the value inside it is 0, so 1 by 6, 0 square plus 0 square plus 0 square, and we will be getting ultimate answer as 0. So on the basis of points, our first line will be getting to 1, 2 and 3, some like this, and assume it is a straight line. Okay, now I say our theta 1 is 0.5 right now. When theta 1 is equal to 0.5, now cost our cost function will be becoming j of theta 1 is equal to 1 by 6 of 0.5 minus, I'm just putting the values inside the formula, nothing else I am doing. 1 minus 2 whole square plus 1 minus 5, 3 whole square, and I am getting 1 by 6 into 3.5, which is roughly approximately to 0.58. Okay, again we will draw inside this. Now it will be coming something over here 0.5 and around 1.5 over here and over something over here. So this line will be going like this. Okay, so like if you multiply that 0.5 into 1, 0.5 into 2 and 0.5 into 3, you will getting all these points, which is 3 point which I have joined right now. Okay, next, when theta is 0, we have done with 1, we have done with 1, we have done with 0.5, and now we will be when theta is 0. When theta is 0, so j of theta 1 is equal to 1 by 6, 0 minus 1 plus 0 minus 2 plus 0 minus 3 whole square, and we will be getting something by 4 by 6, which is approximately to 2.3. Okay, for the line of theta is 0 will be going something on this x-axis only. My pen is not working, like this, and we have to basically find the distance between all these 2 points. Okay, for that okay, now I will be taking, for this I would be taking something like this is 0.5, this is 1, this is 1.5, this is 2, and this is 2.5, and this is our theta 1. Now this is 1, this is 2, this is 3, this is 4, and this is 5, and this is j of theta 1. The lowest point over here is 1, which is also our global minima, and we have a point of 1.5 and 1.5 over here. Next we have 2 and 4 over here, so it will be going something like this over here, and from here it will be going something like this. Okay, so it is like let me use an eraser. So this is the curve which you are getting right now. This point is your global minima and this is your gradient descent. Okay, next. So basically we have to find like this and this, and suppose we have a gradient descent and we have a line like oh, sorry, I'm bad at drawing actually. So this is a curve and we have to get a line, suppose it is touching it, okay, on this and this is a positive slope. Why it is a positive? Because it is moving towards the x and away from y. Okay, this is your theta 1, this is of sigma of theta 1 and this is your global minima. So we will be updating our theta 1 to update derivative slope and then we will find derivative or slope. So basically I want to explain you the repeat converge theorem over here. Converge theorem. What does it say? Theta of j, theta j minus sigma of derivative of by derivative of theta j into j of theta 1 and basically alpha over here. Alpha is, let me write, learning rate and this is our slope in this formula. Now I will close it and write over here theta 1 is equal to theta 1 minus alpha of positive, so it will be decrease, and when theta 1 is equal to theta 1 minus alpha, it would be negative and this is basically our slope. Next, theta 1 is equal to theta 1 and yeah, one outline I want to like say that how to move with it is start with theta 0 and theta 1. Start with theta 0 and theta 1. Second, keep change theta 0 and theta 1 to reduce. Keep changing theta 0 and theta 1 to reduce j of theta j1 until we reach global minima. Until we reach global minima. Third, converge theorem. What is converge theorem? Let me write down that also for you. And this is the last topic. Theta of j minus alpha of derivative of theta j, j of theta naught comma theta 1, and j can be 0 and 1. So this is your converge theorem. Okay, this was the last topic and this was all about uh, our first algorithm, which is the linear regression. Okay, these are all the topics which we have covered so far and I hope you like this video and thank you everyone for watching. Next we will be, I think we will be covering logistic regression and many more algorithms which will be covering. So stay tuned and subscribe to my channel, like my videos and comments if you have any doubts and if you like the video. Thank you everyone.